So this week we're going to talk a little bit about scripting. And scripting is essentially programming, but it's programming in the shell on our Linux boxes. And what this allows us to do is to automate tasks and generally make our server work a little bit better for us and allow us to do less work. And using some of these techniques and using some of these languages, we can automate things on our servers so that we don't have to do them. So I'm going to go through a couple of different scenarios here. Some in languages you are probably familiar with, others maybe not. So we're going to look at PHP again, Bash, and Ruby today. And then I'm going to do some live examples on how you can use these on your server. And then in our lab this week, we're going to actually be learning a little bit of the Ruby programming language, which I think is a fun language to learn, especially for those that don't have much programming experience. And that'll be a nice segue into talking about Ruby on Rails next week and deployment as well. So it'll be a nice segue into that. So I want to introduce you to the DRY methodology, and it stands for do not repeat yourself. I mean, it's typically applied to programming, and what I mean by that is we don't want to repeat ourselves in programming. So for instance, we don't want to have two functions in our program that do the same thing. We want to have each function within our program that does a very discrete and very specific thing within the program so that we aren't adding extra code and extra complexity where we don't need it. Where this comes into play with scripting and servers is that a lot of times when you're setting up servers, especially if you're managing lots of different servers or a bunch of different servers across an enterprise, you may not want to go and install MySQL over and over and over again on each computer, or you may not want to have to go to each server and back up a database, for instance. And what scripting allows us to do is to write little programs that automate those tasks for us so that we're not repeating ourselves over and over again on many, many different servers. So when I say scripting, it's usually in the context of automating commands using scripting languages. And scripting languages are Perl, Python, JavaScript, Bash, Ruby. These are also sometimes called programming languages. They're somewhat interchangeable. I wouldn't go as far as saying these languages are like C and C++ and some of the lower level languages. You wouldn't write a backup script in C or C++, for instance, but you would use Python or Perl or Ruby to write a database backup script. So when you're thinking of scripting languages, think of what I like to call, or what are commonly called, higher level programming languages. So C and C++ are low level programming languages. Those are the types of languages we use to build software like MySQL or Apache. Those types of programs are written in C. Python and JavaScript and Perl and Ruby are higher level languages that allow us to control those software, to control those pieces of software and to control the server. So scripting can be a client and server side, as well as operating system level. So JavaScript obviously is a scripting language for the client side browser. Python and Perl are server side scripting languages, and Bash is actually a scripting language that kind of comes built into the shell that we use all the time. So let's start with Bash, since that comes built into our system and there's not really anything we have to do but fire up a new server to get that running. So Bash is an acronym for Born Again Shell, and that's a Unix shell. So it's the system we operate within when we're controlling our Unix Linux boxes. So the same system that has the cd command and the lsal command, those are all, that's all Bash. So these commands can be combined in files and run as programs using simple control structures and functions. So Bash is kind of a very simple has a very simple programming layer to it, where we can create simple variables and simple control structures to make the server work for us. And typically Bash programs are just an extension of available commands on a system. So we could, for instance, use Bash to run a bunch of apt-get commands to install a bunch of software. So you could create a Bash script that would set up your entire server for you. It would install PHP and MySQL and Apache and the MySQL PHP bindings, and it could maybe even go out and download the WordPress files for you. So here's an example of Bash, and one thing you'll notice is that all Bash scripts, and these would be stored in a file, so these wouldn't be something you would enter into the command line itself. We would actually create a file called file.sh, and we would put this content inside of that file. So all Bash scripts start with this shebang up here, and what this does is this is essentially a comment, but it's a special kind of comment that tells the system where to find the Bash program, basically. So you always want to put this at the top of your file, and then below that you can just add lines that we would typically run on the command line. We can just add them to the file, and they will be run in sequential order. So just from top to bottom, one will execute, then the next will execute, then the next will execute. So this very top program would be very simple. If you ran that, all that would happen is it would just output hello world. The program below it, now keep in mind these are two separate programs here, so you wouldn't want two bin bash lines in the same file. You only need one per file. So this next one down here would actually run a backup on MySQL, and then it would compress that backup to a file called backup.tar.gz. So this is a very, very simple Bash script that would back up a MySQL database. So here's a little bit more Bash, and this is, we're getting into conditional structures and variables. So if we wanted to create a variable here, we can use the uppercase variable name equals and set the variable name. And a conditional, like an if statement, it looks just like this. And Bash kind of closes if statements in a funny way. It reverses the if to fi. So this is just a general conditional statement. So if this, then that. Okay, so the next scripting / programming language I'd like to talk about is Ruby. And Ruby is an object-oriented programming language, and I'm not going to get too much into the nuts and bolts of what that means. When you do this week's activity or this week's lab, you will be introduced a little bit more to object-oriented programming, so you should have a fairly good idea of what that entails once you get through the lesson this week. It's a good programming language and also a very effective scripting language. It was developed in Japan by a guy named Mats, as he's commonly called in the in the Ruby community. And the nice thing about Ruby is that it has a very natural language-like syntax. So it's easy to read, it's generally pretty easy to learn, and it can be a very fun programming language to work with. So here again are the same examples that we saw in Bash, but in Ruby. And as you can see in the Ruby example, we don't need any special line at the top of our file. We just put all of these into a file and save it as a .rb file, and then we can run these from the command line. So we have a puts hello world, and that'll just print out hello world to the terminal. And then we also have our same MySQL backups and our compression scripts here, and they're put inside a system method, which basically runs this command on the system that you're on. And we'll see an example of this in the live version. So here's a little bit more Ruby, again, variables and conditionals. You can see this is a little simpler than Bash. It's a little nicer syntax. We have our variable names up here, and then our conditional is just an if and an end statement, and we can execute on the conditional within that block. So finally, we have PHP, and we've actually worked with PHP not a lot in this class, but you should be familiar with it at this point, at least being able to get PHP scripts up and running. And this should sound familiar from your scavenger hunt lesson month or so ago. So PHP stands for PHP Hypertext Preprocessor. That's a recursive acronym. So the acronym actually is included in the name, which is kind of a open source software thing. They like to be quirky like that and create recursive acronyms. It's probably the most popular scripting web programming language. And although it's mostly used as a server-side language, like in WordPress, WordPress is built in PHP, you can also use it for operating system scripting, which you'll see here. So one thing to notice about PHP is that all PHP scripts, aside from ending in .php, also start and end with these special lines. So we have an open bracket question mark PHP and a closed caret, open caret question mark PHP and then a question mark closed caret. And anything inside that will be executed as PHP. So again, you can see our our standard example we've been using here, the echo hello world. So that'll just print hello world out into the command line. And then we have our same MySQL and backup scripts that will back up MySQL. And instead of the system function, PHP has an execute function, or exec, that will run our commands for us. And as you can also see, all PHP lines, so every line of the programming language, is terminated by a semicolon. So that's very important. If you forget that, your programs will not run properly. So here's a little bit more PHP again, our variables and our conditionals. Pretty straightforward here. One thing you'll also notice are inline comments. So anytime you see two forward slashes on a single line, that will be interpreted as a comment, and PHP will essentially ignore it. So you can write commands or just generally let people know what you're trying to do within your script. So installing on Ubuntu, because this stuff doesn't come built in automatically, except for Bash. Bash is already there, so we can already start using that for our scripting. We have Ruby, which is just apt-get install Ruby and IRB. And IRB is the interactive Ruby shell, and that allows us to actually run Ruby right in the command line. You'll see an example of that a little bit later. And then we should all be familiar with PHP by now, and we all know it's apt-get install PHP 5 and then PHP 5 CLI. And that's important. CLI stands for the PHP 5 command line interface, and that allows us to run PHP from the command line as opposed to just compiled with Apache. So this is an important addition to remember if you want to do scripting with PHP. And you would have had to have installed PHP 5 CLI to properly or to fully complete the scavenger hunt we did a month or so ago. So one last thing we need to be aware of when we're building scripts that need to be executed on our server, we need to make sure that the executable bit is flipped. So essentially this means that we're kind of telling the server to execute this script. It's going to be executable. And we can do that by using the chmod command and then giving it a +x and then the name of our script. And once we do that, we can run these scripts right from the shell, and they will execute in our environment like we would expect. And this will be a little clearer once we get into the live example. So in the next video, we're going to run through each of these scripts. They all pretty much do the same thing, but I'll show you the different interfaces for getting those running. So we'll see you in the next video.